Welcome, everyone, and thank you for joining our session regarding Log4j vulnerability, which is definitely creating the headlines. My name is Yochai Korem. I'm the CEO of Cyberint, and with me is Mr. Shmuel Gifron, which is a leading security researcher in Cyberint. And today we'd like to give you an overview of the vulnerability and what has happened in the last few days since it was let's say discovered or published. The scope today will include an analysis of the rundown of the vulnerability, what is Log4j, and what is so special about this vulnerability that's creating the headlines, and what is the impact of the vulnerability as we see today. Then we'll try to cover what we have discovered in the last week since it has been published. We'll cover some of Cyberint actions in the last few days alongside with recommendations. Later on, we'll go and cover a Q&A. I want to remind everyone there's a panel that allows you to ask different questions. We will review them and we'll answer them at the end of the session. So please feel free to write them as we go along. We'll try to keep it in half an hour, and then if there are additional Q&As, we may go longer. With that said, let us begin. So first of all, what is Log4j? Log4j is a framework under the Java programming language that allows to different programmers to decide which information they want to keep in a log format for debugging, for analysis, etc. This is probably one of the most popular logging packages. We can see it in many applications and services from Facebook, LinkedIn, Tesla, and really thousands and thousands of different services and applications around the world. And what's very unique or valuable, what's special about the Log4j is that it allows not only to take a parameter coming from the website that we want to save on the side, it is also an option to execute or to run commands that are part of the log. So for example, if in the log line includes what we have here in red, $Java version, in this case, the log will go and fetch and look for the specific version of the Java application to be placed within the log file. So it allows programmers to write more simple code and still receive the right information they want for the logging application. Those expressions are evaluated using the Java naming directory interface, GNDI, which is also called lookup, and we will see that in a second. And again, another very valuable and used capability of the Log4j is the ability to go and execute those requests also in a remote location, meaning not only within the web application where the Log4j is actually running. And in order to execute that, there is the LDAP, the Lightweight Directory Access Protocol, which is one of the protocols that is being used in order to execute commands outside of the specific application. Maybe we prepared a small diagram to make it a little bit more understood, as this could be some complex, slightly complex. So here we have a nice person which is trying to approach a web server. It could be a website or application from any kind. And in this in this server, there's the web server itself, for example, the Apache application that allows that renders the data and presents you the outcome. And there's a module within the server that is the Log4j logger, which will log a request that is coming from different users. So, for example, when I would like to go and receive a web page, I will send an HTTP request that includes a header, and in the header, there could be variable or different parameters. And here is a very typical header. You could see it in any web page that you're browsing into. So a GET, I would like to receive the page. The host that I'm targeting or requesting is, in this case, company.com. And I will also provide the server information about who am I, in this case, the user agent parameter, which tells which operating system and which browser I'm using, for example, Mozilla, in a Linux, etc. So these parameters will be sent to the web server, and according to the decisions of the web server, it might decide to log this data within the logger for future statistics. So this is the regular case. Now let's go to a different case where we have a threat actor. And not only a threat actor, but so the threat actor, when they want to begin executing or using this vulnerability or this capability of the Log4j server, they will first set up a malicious LDAP server, which holds the malicious code that later could be used against or within the attack execution. Then the threat actor will try to identify a vulnerable server, and we'll see an example of different techniques to do that. And now, instead of sending a regular command, the threat actor will use the capability of the Log4j server to execute parameters or commands within information that is sent into the log server. And here you can see the threat actor has used a command using the techniques we talked about to go and receive some payload from a malicious site.com, which is in this case our malicious site. And when this information is then saved to the log as any other request coming from any user, the Log4j server will actually identify this is a this is an executable line, and will initiate or execute the command that is written here in the user agent path, and actually will parse the payload and will make the query to the LDAP server. And as a result, the LDAP server, our malicious server, will send the malicious payload to the web server, and the web server will execute this malicious payload. So in this example, we can see the threat actor now, actually he or she has ability to execute malicious payload on the server. And there could be different malicious payload. This could be a malware infection, so a malware that could be commanded or in the future by the threat actor. It could allow reverse shell, again, that allows the threat actor to execute additional applications on the server itself. It could just open a backdoor, sniff information, install a crypto miner, and wipe, in one single command, he could wipe the server itself and other, as you could think of. So we understand why it is so easy and why it is so common. I would want to provide another type of technique that threat actors could use that are simpler in some cases. So for example, in this case, the command in the user agent actually requests from the Log4j module to retrieve a parameter that might be available. In this case, the parameter is the AWS secret access key. So the different tokens that are hosted within the web server in order for the web server to work efficiently. And once this Log4j process or this request, the threat actor will receive the data, or in this case, the secret key. And of course, then the threat actor can take this data and execute other types of attack outside of this context with this secret information that he or she holds. So these are two types of techniques. And Shmuel, maybe you can give us some other things we have identified in the last few days.
Yeah, sure. Thank you. So in the last couple of days, we really tried to understand what's the effect of this vulnerability in the wild. And we were able to find, using our honeypots, many ways which threat actors was trying to use different payload manipulation in order to successfully exploiting this vulnerability or even scan for it. So we have seen base64 encryption payloads. We have seen WAF avoiding attempts using string manipulations. And we have seen that in order to fully exploit this vulnerability, you don't have to use just the payload within the user agent header, as Yochai already showed. We have seen cases in which it's is injected within other headers, such as the authorization, referrer headers and such, and also in the URL paths themselves. So it's not necessarily thing that is just going through, it's not necessarily something that is only have one technique and one special way to exploit it. And more so, the thing with this vulnerability is that it's mostly, and the most common way for threat actors to utilize it is by using the LDAP protocol. But we have witness cases in which it doesn't have to be an LDAP. It can be any one of those protocols that we have listed here, such as HTTP, DNS, which is pretty common. So it's not something that is very, very easy to mitigate. Now, all of these factors, they all lead us to the understanding that this flexibility within how you exploit it and in which way, which protocols, which infrastructures you're trying to attack, all of this led to an all-time high score of CVSS score of 10, which shows the vast scale of this vulnerability. Now, if we wanted to talk about the impact, so as I already mentioned, due to the popularity of the package and the fact that pretty much any ecosystem that we actually know and most of the ecosystems that we use today, they potentially using this package. And furthermore, when non-internet facing Java applications can also be vulnerable. So if you're looking at this example that we have for you right now, we can see that a threat actor can target non-vulnerable internet facing server, but as part of the data congestion and the data parsing that it does with the internal system that this specific service use, it might run into a vulnerable server that runs outdated Log4J package or something with this nature, thus making us having a link within our system that is vulnerable and was already compromised. So this is all of those scenarios make the impact of this vulnerability highly severe.
Thanks, Shmuel. I think in the last few days, our analyst team has going through Argos and trying to see the chatter around it. What can you tell us about the request or the interest of threat actors for this vulnerability?
Yeah, sure. So as you already said, Yochai, pretty much immediately after the CV was released and the POC has been released, we have witnessed a major spike with queries, requests, anything with this nature regarding this issue. So the following, if we look at the graph right here, we can see that any threat actor chatter that we collected from Argos, whether if it's the dark web forums, instant messaging such as Telegram, social media, we have seen a major spike since the 9th of December, which is when the vulnerability has been released. And it's important to understand that this case is pretty special because we haven't witnessed much CVEs that released in the past that caused this much of interest and this much of chatter within those channels. So this is also one other clue that we can have, and we understand that how much this CV is significant to everything we pretty much knew up until this point. Now, here we have another example. This is the first example of an underground forums that we found about I wouldn't necessarily call the threat actor, but still someone that have been already utilized a scanner and developed a scanner that actually does scanning for vulnerable hosts to this vulnerability automatically. And if you can see in the bottom bulletin, you see that it also support the WAF bypass payloads. So this is something that you can also see that threat actors already started to make it more viable to weaponize it with other products.
And I think if I can add, what we see within different threat actors, not everyone has the same technical capabilities, although this vulnerability is quite easy to execute. And we, as we monitor also GitHub, we can see within source code repositories different examples that threat actors share among one another. Here we can see a threat actor, and I'm using the word threat actor because this is a discussion within usually malicious type of a marketplace or a forum. And he or she in this case would suggest that they have a tool that is already easier to operate, which makes it much more easy for almost any 14-year-old that knows there are 2-3 things in computers to go and execute and try to identify vulnerable servers and cause damage with them. So this is one example that we see. There are more than that. I think this is another one, Shmuel.
Yeah, this is also something that we already see. So the POC was released, and we have seen that people trying to utilize the POC itself, because as Yochai already said, making this vulnerability is not a hard thing. It's not something that it's hard to develop. It's not something that is hard to achieve when it comes to the production of a tool that will do that. So as pretty much expected, since the POC was released, a lot of people try to utilize it. And here's just one example out of many of someone that is trying to have a little bit of help to utilize it for its own purposes.
What else do you see, Shmuel, outside, and who is trying to?
Yeah, I think that the repercussions are pretty much as the slide said, they're broad. So pretty much in the first couple of days, we have seen that a lot of scanners, we see scanners scanning aggressively throughout the whole internet, pretty much to see which ports are vulnerable, which services are vulnerable at the moment. And I think that the first notoriously known malwares that utilize it throughout their campaigns was the Linux DDoS related malwares, Mirai and Mostic. And it was pretty much, I think, 2 days after the vulnerability has been released. After that, we can see another evolved technique of crypto mining activities. So crypto mining cyber gangs try to utilize this vulnerability with Kinsync and XMRig. The vulnerability led to a deployment of Kinsync and XMRig. And of course, the ransomware families wouldn't let the opportunity go to waste, and they also adopted it. And we already seen a new malware family named Konsari that was the target's Windows service that already used this vulnerability as the first stage within their campaigns. So unfortunately, and it's the sad truth in a way, but the sky is the limit when it comes to this vulnerability itself. We can pretty much see it everywhere.
So I hope this analysis so far tries to put in a shorts and few slides why this is so easy to use vulnerability and why there is such a big peak in the world. And also because of its, there are many ways to exploit it because it's so found in so many servers. We can see the threat actors trying to use it, and we understand the impact on an organization could be severe. Hence, our recommendations to anyone that decided to join today to verify that what we're showing in the next few slides, including the recommendations, are used with high priority within the organization. It's clear that this is now a cat and mouse game, or to see who is doing it first, whether the world in general is able to patch and create the sufficient protection, or the threat actors be able to use it before others. So with that, I would like to explain a little bit what we have done in the last few days, trying to help our customers going forward. And I do see a question, maybe I will refer to that. Would most WAF try to block LDAP and DNS syntax exploitables? So the answer is yes, and definitely this will be one of the recommendations. However, as we're going to discuss in a few minutes, it doesn't mean that these are the entire potential set of syntax exploitabilities, because we saw there are different cases already. And what we've seen in the last few days are threat actors trying more and more techniques. As you can understand, the Log4J was there for quite a while and hence so widely used. So now people trying to do different proof of concept, which type of protocols, what type could be then. And again, this is the cat and mouse game between, let's say, the WAF vendors and the threat actors to identify this syntax that is not being picked up by the WAF, for example. And yes, we will share the recording later with you, with the members here, so you can go and review it again. So what we have done in the last few days, we see our responsibility as a threat intelligence company to try to help our customers. So what we've done, we developed, I would say, an alpha version of a scanning tool ourselves. So we looked on the code which we see and improved it a little bit. So what we have done, we set up two types of servers. One is a Tor node, which from it we are able to scan different organizations. And what we're doing from our software, we're actually executing an HTTP request with headers that would potentially trigger the vulnerability in different ways, like the user agent and other techniques that we believe potentially could trigger a vulnerable Log4j server. And we are then sending it to all the different servers that we have. This is a non-malicious content. The only thing that it will trigger is a DNS request from the vulnerable server to a DNS domain listener that we have set up as well. And we could actually trigger and see whether the receive DNS request that would, if we would have placed a vulnerable or a malicious content, would be the next stage will be to download this content. So of course, we're not downloading any content, we're not installing anything, but we just want to see whether anyone is calling with a DNS request. So this is what we're doing. And to remind those of our customers that have the ASM module enabled, in this case, we have potentially all the internet-facing assets, of course, the domains, the ports, the IPs. So we have ourselves through Argos, through the ASM module, the list of assets to scan. And upon a request from our customers, and I encourage you to approach your customer success manager, we can use the scanning tool against the different assets that we know within the ASM module. Now, it is important to add to a few more things here. Using the response coming from the DNS listener, we would be able to try at least to identify two things. First of all, whether the host itself is not vulnerable, or whether the WAF was the mechanism to drop the exploitation. So we would try to provide some kind of indication whether the existing WAF configuration is helpful in denying and stopping and blocking those LDAP requests, as one of the participants has asked. But be clear again, this will potentially cover some or what we believe could be an effective exploitation techniques. It doesn't mean that this is, or I can say for sure, it will not cover everything. There could be other techniques that we don't know today, or that will just be new tomorrow. So there's no 100% coverage here of all the different possible exploitations. And even if the WAF has blocked a specific attack vector, doesn't mean there's no other attack vectors that could be used. But having providing these notes, we do believe that this could be a valuable activity on our side to try to help you identify whether there is anything that is problematic or immediately should be handled. Again, the way to, because we don't want just to scan everyone without any request or permissions, we would like those who are customers in this webinar to approach our customer success managers and ask for this. And if you don't know who, then of course you can use our support at cyber.com for this as well. So this is a little what we have done. And, in the last few minutes we have, Shmuel, maybe you can take us, as you've led the research here on this vulnerability in our research team, what will be your recommendations to the audience today?
Sure. So the recommendation is pretty much divided to two separate groups. If we're talking about application owners, so of course the trivial and the first priority solution that we can recommend for this situation is version control, which means to update the Log4j version to 2.15 and above. Now, a quick note about it, 2.15 version have have led to another vulnerability, which allows threat actors to utilize denial of service attack, which also got patched in 2.16. So if version control is possible, and if you already didn't patch it, we recommend to patch it to 2.16 and not 2.15. Now, if it's not possible, so of course, if you're modifying the flags and environment variables regarding the format, the log4j format message no lookups to true, as you can see in this example. So if this is something that will also have mitigate this the situation, and of course, mitigation is also available if you just remove the JNDI lookup class from the class path. Now, this is in the last bulletin, you can see that this is one of the ways to do it, but of course that for each application owner, it might vary. Now, the second type of recommendations that we would like to talk about are more general. Now, for third-party services, whether if it's third-party services, public cloud services, and supply chain products, we recommend reaching out to those vendors in order to make sure that they have this vulnerability patch within their systems also. So they also might mitigate and detect this vulnerability. And another solution that we might suggest is making sure that your web services or IPS IDS products that are being used within your organization or within your systems supports this CVE also. Now, one of the things that we do as soon as the vulnerability was published was to release our blog post about it. So we highly recommend to read this also, which gets a little bit more into details and offers more knowledge about the vulnerability and its impact.
Well, thank you very much. I think one of the challenging part with this, of course, if it's your application, then go and execute the previous slide of recommendations. But as most of us use third-party applications, here we actually rely on our supply chain to go and improve or update the Java version or the Log4j version. So we would recommend organizations to map the critical applications and actually approach the vendors to identify whether or to update them, whether they have done so. I can share with you here that Cyberint product is in general not using Java, and this vulnerability does not impact Cyberint product. So as a vendor, we here proactively update you that we should not be on your worry list, but you should make one and you should approach your vendors to identify this. And we'll continue to update through our blog, and of course, Argos users will receive it also as notifications in our report section. So I would like to open the next few minutes for questions. I see already one question from one of our audience, and I'll read it out. So how to check if a Windows server is vulnerable, and if not facing the internet, what to look for? Thank you. Maybe Shmuel, you want to try to address it.
Okay, so how to check if the Windows server is vulnerable and it's not facing the internet? So, well, basically there are several tools that are already out there, out of the ones that we offer at the moment, as Yochai already mentioned, that might do some checking if you input some your assets, such as IPs or domains that you have, but it's not. We do not know if necessarily it will identify 100% if you're vulnerable or not. So this is not something that we can take responsibility of. But the main idea of this vulnerability itself is just that at the end of the day, it depends which services you run on your applications, on your servers, and you should try to understand or try to know if there's any case which the Log4j is part of the equation, is part of the process. Mm-hmm. So this is pretty much.
For example, Shmuel, I think we know that most Apache servers would have Log4j as part of the configuration. Exactly. and thus, this could be a target to see which web servers you have that use Apache. And I think we can take on ourselves as maybe follow up to these questions to publish or share with the audience the main applications that we know are commonly used Log4j as part of the default or standard configuration, and those of course will be the right target. We can also share as an outcome to this webinar some source code that could be used to compile a parser, or sorry, a scanner. And in this case, the scanner should be then run or executed within the network interface or within the network that you own, using one of maybe the scanning tool, other scanning tool that you have. So we can definitely point you to code that will allow you to do this easily and try to identify. Yeah. So thank you, Raymond, for these questions. Again, any other questions from the audience? Please feel free to write here in the Q&A session. Okay. Then, if this is the case, I would like to thank you for joining. Again, our responsibility as Cyberint here is to continue track the threat actors, how they evolve and utilize and weaponize this exploitation or this vulnerability, and try to provide our customers with an early warning or different suggestions on what to do in order to be more protected. Again, as a final note, this is a critical vulnerability. It didn't receive the 10 mark for the CVSS score just for nothing. Verify that you stop your day-to-day activity and set with your team and with the management and define what is your action plan to try to mitigate it before it's too late. Within 2-3 weeks, it could be too late for organizations who have not done that. And again, thank you very much for the time today.
Thank you, everyone.